Okay, welcome to Small Academy. So this is our first video lesson together, so I hope it goes well for you. Remember that with these video lessons, if you get confused at a part, you can always pause it and rewatch that part, and hopefully that'll help you a little bit. So today we're going to talk about graphing transformations, part 2. So last day on Thursday, we looked at the values of k, which was the shift up and down, and the values of a, which was how it was stretched or compressed, or if it was negative, how it was reflected across the x-axis. So today we're talking about the value of h and how it affects the graph. So obviously I'm not there to look at practice questions with you. During the homework time today, feel free to ask those questions of people around you or save them for tomorrow when I am back. We already did this, but let's talk about just the base parabola again. Because whenever we talk about transformations of parabolas, we need to go back to the y equals x squared, which is our base parabola. Okay. So if my computer cooperates, that'd be fantastic. Great. So from our values, x squared is just this value times itself. So 4, 1, 0, 1, 4. So plot our points. Negative 1, 1, negative 2, 4, and there we go. Okay, let's see how my parabola looks today. Let's do a nice blue. Not too bad. Cool. Okay, so this is our base parabola. Remember, the vertex is the lowest point or the highest point, depending on the opening. So our vertex here is 0, 0. Direction of opening is up. And equation of the axis of symmetry is x equals 0. Remember the step pattern? That is the steps we take to get to the nearest point, or the next point. So go up 1, over 1, up 3, over 1. So the step pattern for the base parabola of y equals x squared is 1, 3, and 5. Okay? So that's the base parabola. Horizontal translations. So that is what the value of h does to our parabola. H is left and right, k is up and down, and a is stretch or compression. Okay? So for h, this is what it looks like. The general formula is y equals x minus h squared. Okay? If we have y equals x minus 2 squared, I'm going to ask you to pause the video and to calculate these by yourselves. Okay, and see what happens with our parabola. So maybe you paused it, maybe you didn't. Well, let's go through it. So if x is 0, then we do 0 minus 2 squared. So it'd be negative 2 squared, which is 4. 1 minus 2 squared would be negative 1 squared. Is 1. 2 minus 2 squared is 0. 3 minus 2, which is 1 squared, is 1. And 4 minus 2 is 2, and 2 squared is 4. So these points, the y values at least, are very familiar to these ones. But remember, the x values are different here. So let's plot our points. So you have 0, 4, 1, 1, 2, 0, 3, 1, and 4, 4. Let's do ugly orange. Ooh, not the best parabola. Let's try that again. There we go. That is a better parabola. Okay, so let's examine our information here. So our vertex now, up until now, our vertex either moved up or it stayed the same. So 0, 0, or moved up and down. Now it's shifted to the left. So now it is 2, 0. Direction of opening is up. Look at our equation of the axis of symmetry. It's not x equals 0 anymore. Remember from before that the equation of the axis of symmetry is actually our x value of our vertex. So in this case, our equation of axis of symmetry is x equals 2. Okay? So right here, vertex, the equation of axis of symmetry would go right through x equals 2. And our step pattern, did it change? Up 1, over 1, up 3, over 1. So no, it's the same. Okay. So that's the graph for y equals x minus 2 squared. X plus 3 squared. So here would be a great opportunity as well to pause the video, give this part a whirl, and see how it goes. So you can pause now if you want to. And if you didn't, we're going to go ahead right now. So x plus 3 squared. So we have negative 5 plus 3 squared. So negative 5 plus 3 is negative 2. So we have 4. Negative 4 plus, that's negative 1 squared. That's 1, 0, 1, 4. Okay, so we have similar y values again, but the x values are different. So negative 5, 4, there we go. Negative 4, 1, negative 3, 0, negative 2, 1, and negative 1, 4. Now that point looks sloppy. There it is. What color? Let's do bright green. That looks great. Cool. So here our vertex has shifted to the left. So the x value is negative 3, y value is 0, direction of opening is up. Equation of the axis of symmetry, okay? So that is where, if we drew a line down the middle of a parabola, where would it be symmetrical? So that would be x equals negative 3. And our step pattern, did it change? No, up 1 over 1, up 3 over 1. So still 1, 3, 5. Okay. So the h values are left and right. So when you're looking at the sign of your h value and the direction of it, notice here it was plus 3 and it moved to the left. Here it was minus 2 and it moved to the right. So when you're looking at transformations and what's happening to our parabolas, you need to remember that this is the opposite of what you think. So usually you think if it's negative, it's going to the left, because that's where the negative values are. But with parabolas, because our formula started with x minus h squared, it's moving to the right, but it's going to be negative here. Okay, so be very, 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 very careful with that. So in summary, okay, so if h is positive, the parabola shifts h units to the right. Okay, so remember, our equation here is y equals x, or a x minus h squared. So if h is positive, the parabola shifts h to the right. And how this would look in an equation, so if we have an example here, y equals x minus 5 squared. So our h is positive, so it's going to look negative in our equation, okay? Because we're just subbing in, for 5, we're just subbing that into our equation, and it's going to be negative in our equation. So this one would shift 5 units to the right. Okay. If h is negative, the parabola will shift. Oh, I didn't say units up there. H units to the left. But remember, because there's a negative sign in our equation up here, okay, in our example, let's say we had a value of negative 6 as our h value. When we put that into our equation, it's going to turn that into a positive 6. Okay, so here it'll be shift 6 units to the left. So try to not let that confuse you. If your h value is positive, it'll look negative in the equation. If your h value is negative, it'll look positive in the equation. Okay. So just remember, if you see a positive in our form of our quadratic equation, positive is going to be moving to the left h units, negative to the right h units. Okay. When we eventually get to graphing these quadratics with transformations, the order of what you do is very important. So first, you do any reflections. Okay. So this is with our a value, if a is negative. Second, any vertical stretches or compressions. Okay. So this is if a is greater than 1, we do stretch. If it's less than 1, between 0 and 1, we do compressions. So that's our a value. Once those two are dealt with, then you do your vertical and horizontal translations or shifts. Okay, and this is our h and k values. Okay, so I think tomorrow we'll be looking at actually graphing these quadratics with all these transformations applied to them. But for today, I just wanted to let you know that there is an order that you have to do them. It's kind of like BEDMAS, how you have to do multiplication and division before addition. Similar here. You have to do the vertical stretches and compressions before the translations or shifts. Okay? Now that we've looked at each component individually, this is the general formula for a quadratic. Okay? This is with all the pieces together. So our a value, so that deals with reflections, there we go, and stretches and compressions. Okay. Our h value, so that is our horizontal translations. And our k value is vertical translations. Okay. So when you're asked to graph a quadratic or asked to explain what's happening with a quadratic for translations, these values will most likely be given to you. And then using those, you can describe what's actually happening with a quadratic, like this question here. Okay. So describe the following transformations. So for this question, I want you to just explain what is happening. Okay. So first thing is reflection. There's no reflection. Then we look at our stretches or compressions. Okay. So it's a 0.1, so that means it's between 0 and 1. So it is vertically compressed by a factor of 0.1. Okay. Remember, if our a value is between 0 and 1, it's going to be compressed. If it's above 1, if it's greater than 1, it's vertically stretched. Now let's look at our -2. So this is our horizontal shift. So it's a negative there. So remember that if it's negative here, that means our h value is positive and it's horizontally shifted. Oh, cannot spell. Today. So horizontally shifted. Right 2 units. So if it's negative, it's being shifted to the right. And then our plus 3, so vertically shifted 3 units. So remember, with this one, with the k value, it's a bit more simpler. If it's positive, it goes up. If it's negative, it goes down. Okay, and those are the transformations that are applied to this quadratic, this parabola. Here, y equals negative 2, x plus 3 squared minus 5. So here, there's a negative sign. So we do have a reflection. So reflection across x-axis. Now we look at the 2. So it's greater than 1. So it's vertically stretched by a factor of 2. Okay. Now let's look at our 3, our h value. So it's positive in here. So that means our parabola is being shifted left. So horizontally. Translated 3 units left. And last but not least, we have negative 5. So vertically translated 5 units down. Okay. So those are all the transformations that are applied to that parabola. So remember, we do have a nugget on Wednesday. So there'll be stuff on today and tomorrow. And here's your practice. It's not too much, right? It does look at our h values from today and kind of putting it all together and describing those transformations that have happened. So if you find yourself stuck and you need a little refresher, remember you can come back and watch a video over again. And I hope you have fun, and I'll see you tomorrow.